So good morning. So we are continuing, Miss Pender and I, exchanging video duties for our lessons. So today I'm going to be working on operations with polynomials. She left off with operations with monomials. And we both talked yesterday about the common errors that we saw in your homework assignment. So I thought I'd address those two things right now before moving on to the new lesson. And one other thing. So we all know this is just kind of a weird and unusual time, and people are cooped up in their houses, and maybe you don't see your friends as much and stuff like that. So please make sure you're taking care of yourselves, and reach out, connect with each other, and also if you're feeling like you really need to, check in with somebody. Ms. Morin and Ms. Bazillion have set up a Google Classroom page. And so you can join that page, I think, and maybe check in with those people if you need to do that. Okay, so the two most common errors from the homework were negative coefficients and not dealing with them properly, and also negative exponents and the entire expression and how to deal with that. So here's the first kind of error that I saw right here, which was multiplying these two types of things together. So remember, only things that have negative exponents move their location. Not anything that's negative, just things that are negative exponents. So in this case, what I saw for many of you was you saw a -3 as a coefficient. You said, oh, hey, that's negative. So anything with a negative has to go into the bottom. And so what you did was you multiplied the x squared times the x to the fifth. That's cool. Y cubed times y. That's cool. You left the 5 on the top. That's fine. But you dropped the -3 into the denominator, and that's not fine. This is just a coefficient, it's not an exponent. Remember, only things with exponents get a chance to move. So what we should have here is -3 times +5 is -15. And then x squared times x to the fifth is x to the 7th. And y cubed times y, remember that's y to the first, right, is going to be y to the 4th. And like I said, many of you, or not many of you, I shouldn't say many, but some of you were taking this 3 and dropping it into the denominator, and that's not correct. Okay, here's the other thing that I saw. So we have 4x to the third, y to the -2nd, and I know there's no operation here, but what was happening for some of you was you were saying, oh, there's a negative exponent, so what I'm going to do is I'm going to write this whole expression in the denominator. So what you would write, and this is not correct, is you would be writing this, 1 over 4x cubed y squared, and that is not correct. Only the thing with a negative exponent moves, and in this case only the y has a negative exponent. The 4 and the x cubed, not negative exponents. So this is not correct. So what should happen is only the y should move to the denominator. So this is going to be equivalent to 4x cubed over y squared. So only the y squared goes into the denominator. Okay, so that clears up the two errors that I saw. All right, so before we jump into operations with polynomials, we should probably know what a polynomial is. So a polynomial is the sums and or differences of two or more monomials. Remember, monomials is what Ms. Pender worked with in the last video. There are no negative exponents, no variables in denominators, and no square roots. So here are a couple of examples of things that are polynomials. So x squared plus 3x plus 2, quadratic, we've seen lots and lots of those, that's a polynomial. We can have polynomials with multiple variables. 5x to the third, y to the 4th, minus 10x squared y, plus 11x minus 19y. They don't all have to have multiple variables. So this is an example of another polynomial. If this said 19 over y, that's not going to be a polynomial. Remember, no variables in denominators. If this said 11x to the -3rd power, not going to work. No negative exponents. If this was 19 times the square root of y, not going to work, right? No square roots. So these are polynomials, and the examples I just gave are not polynomials. The other term we need to have is the degree of a polynomial, and that is the highest power or sum of powers in the terms of a polynomial. So back to our two polynomials up here, we see that the powers of these terms are power of 2, power of 1, right? 3x to the first, power of 1, and this has no variable, so it's a power of 0. So we have powers that are 2, 1, 0. The highest power of 2, 1, and 0, of course, is 2, so the degree of this guy here is 2. So this is degree equals 2. And then we look at this guy right here, and we talk about either the individual variable powers, or if there are multiple variables, the sum of the powers. So let's take a look right here. So the degree of this term right here is going to be the sum of the two powers. So 3 plus 4 is 7. The degree of this monomial right here is 2 for the x and 1 for the y. That's going to be 3. And this has an 11x to the first, so the power here is 1. 19y to the first, the power here is 1. So I got 7. The power of this, or the degree of this monomial is 7. The degree of this one is 3. The degree of this one is 1. The degree of this one is 1. The highest of all those is 7. So the degree of this polynomial is 7. So degree, it's easy. And I think that's all. Oh, like terms. That's the last term, last idea I have on this page right here. So like terms. Terms, these are monomials again, what Ms. Pender worked with. Terms that have the same variables and powers of those variables. So let's take a look at what those look like. So these are like terms. So we got 3x to the fourth power, negative 7x to the fourth power. Same variable, same power. The only thing that's different is the coefficients, and that's fine. They can be different. We can also have multiple variables. So in this case, we have 2. We have x to the cubed, y to the 8th, x to the third, y to the 8th. Different coefficients. These are like terms. Same power, same variables, same powers of the variables. These guys are not. 7x squared, 8x, not like terms. Same variables, not same powers of the variables. Okay. Adding and subtracting polynomials. All we need to do is just add or subtract the like terms. That's what we talked about, like terms up there. So here's our first example. Easy enough. So we got 3x squared plus 2x plus 5 added to 7x squared plus 5x minus 2. All we're going to do is add the like terms. So we look for the variables and the powers that are the same. So we got x squared here, we got x squared here. We're just going to add them together. We got 3 of them here, we got 7 of them here. That means we have 10 of them. And then we do the same thing. We just move down from highest power to down to lowest power, just to keep things systematic and orderly. So we got 2x here, and we're going to add to that 5x, which makes 7x. And then we got 5 and negative 2. 5 and negative 2, of course, is just 3. And that's it. That's all there is to it. Just add in the like terms. Sometimes the terms are not in the order that we expect. Sometimes we have powers that are not lining up completely. So for example, in this case, we have 9x cubed in this polynomial, but there's no x cubed over here in this one. So that's fine. We're just going to add 9x cubed to no x cubes, which is just going to be 9x cubed. So 9x cubed plus nothing is 9x cubed. So we got 9x cubed. And then we go down the powers and we get to squared. We got no squareds here. We got an 8x squared here. So we have nothing for x squareds plus 8x squared. Nothing plus 8 is 8x squared. And then we go down to the next power, which is the power of 1. We got negative 4x to the first here. We got 11x to the first here. Negative 4 plus 11 makes 7x, or 7. And these we're talking about x's, so it's 7x. And then we have the constant terms. 7 and negative 10 is negative 3. So this is an example of just working with polynomials that don't have all the same, or all the like terms matched up. This one had an x cubed, this one didn't. This one had an x squared, this one didn't. Totally fine, we can still work with that. Okay, so the other complication that can be thrown at you is the terms are not in descending order. So here we have to the first power, to the second power, to the 0 power, and something different over here. And that's fine. Again, we just need to go, I would recommend, starting with the highest power and working your way down. So we see that the highest power is 2, and we got 2 of those. So we got 17x squared added to 11x squared, and that makes 28x squared. Next power down is 3x to the first. So 3x plus negative 7. So 3 and negative 7 is negative 4. So we get negative 4x. And here we have negative 11 and positive 12. negative 11 plus 12 is plus 1. So we, again, are just making sure that we go systematically in order so we don't get lost. And we went from highest power down to lowest. So this is your opportunity to try things out. So what I want you to do is just, in a moment, hit pause and add this together. And again, notice that the variables are not in the order that we're expecting. So I kind of wanted to make sure that you got a chance to struggle with that a little bit. So right now, take a moment, pause the video, do this problem, and we'll be right back. Okay, so it's really important that you really do pause the videos and actually try the problems out on your own, because this is when you get a chance to know whether you really know it and get a chance to figure out the kinds of mistakes that you're making. So please don't just watch us doing the push-ups. You know, we're already good at push-ups, so and we're going to get jacked, but you're not. So please make sure that you're doing the push-ups also. Okay, so we're going to go right across like I talked about earlier, find the highest power. So we got 5x squared. We're going to add that to 3x squared, which makes 8x squared. And then we go to the next highest power, which is 11x, and negative 8x is plus 3x. And we have negative 2 added to 7, which makes 5. And we are done. And hopefully got that right. Okay, let's move on. All right, so subtraction. Subtraction is really the same thing as addition. And I'm going to recommend two methods here. Multiply by the negative 1 method, for those of you who may be struggling a little bit with negative signs or signed numbers. And then there's just the just subtract method. So let's talk about the negative 1 method. So whenever you see a negative sign in front of us of parentheses with a polynomial inside, we can really think of that as a negative 1 on the outside of that parentheses. And we already know how to deal with that because we know how to change all the signs, which is really all that's going on. We're just changing all the signs here. So in this method here, we're going to keep the first polynomial the same as it is. So we're going to write 8x squared minus 9x plus 2. They're going to multiply all these guys by negative 1. So negative 1 times 5x squared is negative 5x squared. And negative 1 times 2x is negative 2x. And negative 1 times negative 4 is positive 4. And then we just put the like terms together, just like we did just a moment ago. So we're going to add 8x squared to negative 5x squared, which makes 3x squared. We're going to add negative 9 to negative 2, right? Negative 9x and negative 2x, right? We don't need to worry about that sign. We're just looking at this one and this one. So negative 9x and negative 2x is minus 11x. And lastly, we have the positive 2 here added with the positive 4 here, which makes 6. So that's the multiply by negative 1 method. And again, those of you who maybe get a little confused with signs, this may be a useful way to go. There's also the just plain subtract method, just as it is. So we can go straight across, ignoring the negative 1 there, but there's still a minus, so we just look for the like terms. So 8x squared minus 5x squared, 8 minus 5 is 3. So that's 3x squared. And we got negative 9 minus 2. Negative 9 minus 2 is negative 11x. And that's fine. And we got 2 minus negative 4. So subtracting a negative is like adding a positive, so it's really 2 plus 4, so plus 6. Same answer, obviously, a little quicker. But if you struggle with negative signs, you might want to use the first one. Okay, so let's apply all that to this next one here. And again, I've mixed up the order of the powers on purpose, and I've also skipped some powers. So here the highest power is x to the third, and there's no x to the third term here, so we start with that. So we have negative 12x cubed minus nothing. So we have negative 12x cubed. And then we go down to the next power down. Actually, you know what I'm going to do? I'm going to multiply through here by negative 1, as I suggested up there. So I'm going to have 7x minus 12x cubed plus 5, multiplying through by negative 1. And that's going to give us plus 8 minus 5x squared and plus 2x. Okay, so now I'm just going to go through and find my like terms. So I already took care of the x cubed term. Now I'm going to go for the x squared terms. And there's only one of those. It's negative 5x squared. And then we go down to the x terms, and we got one of those here, 7x, and we got positive 2x makes 9x. And then we just go to the constant terms. 5 and 8 makes 13, and we are done. Okay, so you try. Again, this is your turn to do some push-ups. So you're going to try this on your own. Again, pause the video, do the problem. We'll check back with you in a minute. Okay, so again, hopefully you paused the video and you actually did the work, because this is where you really get a chance to practice. So again, I'm going to recommend the multiply through by -1 method. So we got 8x squared minus 3 plus 6x, multiply through by -1, and we got negative 7x cubed plus 4x squared minus 8. And then we just collect all the like terms. So we look for the highest power, which is x cubed, and we got a -7 of those. So we got negative 7x cubed. And then we go to the next highest power, which is squared, and we got 8x squared here. And we got 4x squared there, so 8 and 4 makes 12, plus 12x squared. And we got 6x and no other x's, so that's a plus 6x. And we have a -3 and a -8 to make -11. And hopefully that's what you got. All right, so we are 16 minutes in, so I'm going to try to wrap this up as quickly as I can. So now we're going to go on to multiplication. And we're going to multiply a monomial by a polynomial. So we are going to multiply, as I said, a monomial, a single term, by a multiple or several terms. So we're going to multiply 3x squared times 5x squared. So we're just going to multiply the coefficients, just like you did when Miss Pender gave her video. And then we're just going to add the exponents, because that's what we do when we multiply. So we do 3 times 5 is 15. X squared times x squared is x to the 4th. And then we're going to go on to the next term. So we're just going one at a time here. We're going to multiply this one, then we're going to multiply this one, then we're going to multiply this one, right? Just the distributive property is really all we're doing. So 3x squared times -2x, so 3 times -2 is -6. And x squared times x is x to the 3rd. And then lastly, we have 3x squared times 8 is plus 24x squared. All right, now we don't only have to have single variables, we can have multiple variables, but that's okay. Remember, all we need to do is just add the exponents and just keep ourselves organized by going one variable at a time. So we got 6x cubed y squared, and we're going to multiply that by this one, and this one, and this one. So it's just the distributive property. So we do 6 times 7 is 42. And x to the 3rd, we just work with the variables that go together, right? X to the 3rd times x to the 2nd. Remember, we add the exponents. X to the 5th. Y squared times y squared. 2 and 2 is 4. So that gets us that term. Then we do the same thing over here with the 8x y cubed. So 6 times 8 is 48. X cubed times x to the 1st, remember that's the 1st, is x to the 4th. And y squared times y cubed is y to the 5th. And then we have the last term, this term times the last term. So we're going to multiply 6 times -2 is -12. X cubed times x is x to the 4th. I'm running out of room. I'll manage it. And we got y squared times what we really consider to be a 1 there. There's no y, but we can say that there's a 1 there. So we're just going to tack on the y squared at the end. So there's a y squared right there. Sorry, I squeezed that in. So there's a y squared, and that's that. All right, so you're going to try this one all by your lonesomes right here. And yeah, so pause the video, try this problem, and we'll be right back. Okay, so hopefully you got a chance to try it, and it went well. So we're going to multiply the first term by 1, 2, 3. So 5 times 6 is 30. X squared times x to the first, remember there's a 1 there, is x to the third. And y times y cubed is y to the fourth. We do the same thing over here with the next term. So 5 times negative 7 is negative 35. X squared times x is x to the third. And y times y is y squared. And then the last one, we have 5 times 3 is 15. X squared times nothing here in terms of x's, so we just have the x squared, that's fine. So we got x squared, and we got y times y is y squared. And we are done, and hopefully that's what you got. So I'm gonna call it right there, even though there's more to the lesson. We're already at 20 minutes, 21 minutes. So so this is your lesson for the day, and we will post the lesson and an assignment, and good luck, and we will see you on, what day is today? Today is Thursday. We'll see you on Monday.